Hi everyone, and you are all very welcome along to tonight's webinar on integrated pest control of two-spotted spider mite. We are joined by Davidson of Koppert Biologicals, which will go through an integrated approach to controlling two-spotted spider mite, in particular in ornamentals. Just a few housekeeping rules before we get started. Everybody is in mute and your cameras are turned off. If you have any questions that you would like to ask David, just put them into the Q&A function or the chat function, which is located at the bottom of your screen on the right-hand side. There is basis points and Naruso points available as well for anybody that's in attendance that requires them as well. Just drop me your basis or Naruso number and I'll be able to send that off. And the webinar will also be recorded. If you have to drop out or if you can't get to the full webinar, it will be recorded and made available on the CAFRE YouTube channel, which I'll send out a link once it becomes available to everybody here in attendance. And yeah, I'll pass you over to David now, and he'll introduce himself and introduce what he's going to present to us tonight.
Hi, for those who don't know me, then I'm Davidson from Koppert Biological Systems. So I cover anything to do with biological control for pests across a whole range of horticultural crops. We also do some disease advice as well, pollination. So I work for a company called Koppert. As I said, Biological Systems is the Dutch company, but now it's a worldwide company actually. So the headquarters is in Rotterdam in Holland, but we're all around the world really now at this stage. We're the largest biological control company in the world. Tonight we're going to be talking about spider mite control and how you can integrate using biologicals along with some pesticides if necessary to control spider mite, which is a very common pest. So let's open up the presentation. So I share that, of course. So, share bar. Okay. Go to the right slide. Sorry about that. There we go. Oh. So tonight's talk's called IPM of two-spotted spider mite in ornamentals. And the word two-spotted spider mite is the correct terminology. Some people might say red spider mite, but you should actually call it two-spotted spider mite. The reason being that the pest has two spots on its back. And it covers a wide range of crops, also edible crops, but tonight we're focusing on the ornamental side of things. And you all probably know what spider mite looks like. So this is a very messy leaf with a high population of spider mite on it. So you can see the eggs, the adults, and the juveniles. So here's the juvenile here, the egg, juvenile, adults with the two spots, and then they shed their skin when they molt as well. So you can see the skin being shed. Okay. This picture here shows a spider mite on the stem. So we're going to be looking at different types of spider mite. Just to mention 4 different species of spider mite, but the one we're focusing on is the first one today. But it's always nice just to paint the picture and explain there's more than one type out there that you could find across the UK and Ireland. Well, hopefully the 4th one you don't find, but the other 3 can be found. So we'll just talk about each of them in turn, and then what we're going to do is also mention the insects that actually kill these pests, which Koppert are involved in advising on. So we'll mention 3 different predators for these pests. So the first one then is the two-spotted spider mite, and basically it's very common across a whole wide range of horticultural crops. Anybody who's grown crops at all will know this pest and will have seen it at some point. Let's hope you haven't had any real problems in the past year or 2 dealing with it, but it's a very common pest for me to come across. Another spider mite, which you may have heard of, is Panonicus ulmi. Okay, the European red mite can be found in orchards, can be found in small glasshouse fruits sometimes. I don't come across it in my line of work that much in a glasshouse or tunnel situation. Then we have the citrus mite. Okay, so the citrus fruit mite, Palinonychus citri. I do come across this in ornamentals. Sometimes it's found on shrubs. You might find it on skimia, for instance, and it can be quite damaging. The bad news is that it's more difficult to kill biologically, but there is one of the biological controls that we're going to talk about that does have some effect. I'll mention that in my talk. And then here's another type of spider mite, which I hope you don't come across. It's found in Africa at the minute on Solanaceae species, so anything to do with related to potato, tomatoes, that's where it could be found. Let's hope it doesn't turn up on Northern Ireland, but it's just to make you aware there's other things lurking out there around the world, different species of spider mite that could end up here through imported plants in the future. So the one we're focusing on tonight then is the two-spotted mite. So this occurs all around the world, very common species around the world. Unfortunately, it covers a wide range of crops, as I mentioned. I suppose the one I come across it most because I spend most of the time walking this crop is strawberry crops. So it's a very common pest on strawberry crops. It comes actually on the propagated plants very often. So quite often I will have to check plants that have arrived in a nursery to see if they're actually there. And I would say maybe hard to put a percentage on it, but certainly more than 10% of the time I will find them on the plants. So that's the first thing I check for. I'm sure the same thing would occur for ornamental crops being brought in from various propagators. You may find these spider mites on them. Let's hope not, but you may. What I would like to mention, I was quite alarmed to make the realization that they can seem to survive being frozen or partly frozen. I've seen plants that have come in frozen and defrost, and then the spider mites start moving on the plants. So don't expect to kill them that easily. They're very, very resistant, these pests. Spider mites very resistant to the cold. We're going to talk about how fast they grow the population in a minute or two. So here's the life cycle. You can see it. So you've got the egg, and then you've got your larval stage with the hatchling. Then you've got your protonymph, and then they keep molting and getting bigger. So you've got your judo-nymph, and then you've got your male and female adults. You can see the female is bigger than the male. You can quite easily see that when you're looking at them in the hand lens. Just so. Right. So, obviously, you probably know that most of the feeding damage is on the underside of the leaf. And this is quite typically yellow dots. You will find webbing. So what's happening here is they're basically sucking away the cell content, and it means then it's stopping the plant photosynthesizing. Okay. You will quite often have like localized spots where it builds up quite a lot. So if it's not coming in on the plants, you're probably going to find that in localized areas, quite often the same area each year. There could be a problem spot on the nursery. Quite often that could be something to do with maybe where the fans are located. So they've overwintered in the fans or in the structure. They come down in that spot. It could be something to do with maybe a weeds in a certain area. Like I go to a tomato nursery and I can guarantee I know where they come from every year because there's brambles and also wild strawberries that seem somehow to get in through the foundation structure wall, creep in, and then the spider might break out from that area into the crop. So they will be living on the native plants and they will come from them. So that's something to think about. If it's more widespread across the glasshouse, then you have to probably point the finger at maybe it's coming on the crop on the plants. So it's probably, and that's why it's more widespread. Otherwise, it's probably more local, and it'll come from a source local on the nursery. Now, this spider mite, this pest will, as it says here, will increase more quickly on a generative crop. So that means a crop that's not lush and green, a crop that's more into fruiting and flowering under a bit of stress, heat stress, and so on. You will get a faster development of this pest. Now, I was going to try and show a video, but there's no sound. But we'll have to go back out to my presentation. But we'll have a little. We'll just see what it's like, even without the sound, just to so you get a feel for what this pest would look like. It's just in reality, if you haven't already seen it close enough. So we're just going to play this video.
Just see there, David, did the setting come up that time
Okay.
before you share
Well,
it?
stop that. We'll stop that. We're going to go back to share. So let's go to share. It might work. It'd be
You
great to
should
do it.
you should see a setting button in the corner of your share.
I click it. Okay. Where now see just see share. If I click share, no,
Yeah, and when you come up,
no, it's not giving it to me.
you just went back into your presentation again.
All right.
So
Sorry about this.
stop
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 sharing.
sharing that.
Yeah. Yeah.
When you press the share function at the
Okay.
bottom, it'll bring up your options of what you would like to share.
Okay. Yeah. And this one.
And before you share your video, is there any settings there to ask for optimizing?
No.
Okay.
Not actually. Let's see. Nothing came up then, unfortunately. I should see. So it'll be without audio.
You
Can you hear anything? No.
you could turn on the subtitles, see the
Why
if you would
not?
like to.
We'll see that.
That button there that you're on, yeah. There we go.
So now I'm just going to go back down to my presentation. So click share again, Mark. So that gave you a feel for the pest. One thing that was mentioned there was the fact that there's a lot of resistance. I've come across that myself, where several different pesticides just stop working. I'll maybe not mention the pesticides by name, but certain pesticides didn't work, and that sort of forced the hand of a grower to focus more on the biocontrol. Here's the damage. You can see various damage. You can even see the webbing here from when it gets quite severe, and sometimes find thousands of spider mites in this webbing. And then what actually happens is the webbing starts to break away. Some spider mites hang on to the webbing and they use it like a parachute. And the air currents carry the webbing up into the air. And then the spider mite can be transferred to other parts of the glasshouse quite easily just in the air currents. So they can move that way as well as crawling along between plant and plants, getting on people's hands, getting clothes, equipment, just going on structure across the across the actual steel structure to move around. So it takes 10 days at 27 degrees from an egg to an adult. So that's quite a quick life cycle. Females lay, you can see here, 68 eggs a day. Each female can lay 100 eggs. And the development does depend on these different environmental things, temperature, relative humidity, and the plant that they're living on. I want to talk about diapause with you now, because diapause is basically their way of overwintering. So they go into this bright orange coloration and they stop feeding. They also get a tougher back on them, which means that predators find it hard to break the back off them, to bite into them, to kill them. So they're more resistant against predators when they're in this sort of diapausing phase, this bright orange phase. Okay, so they tend to turn this color in the autumn. The temperature basically sets it off, and you start to see some of them changing and some of them still not changing through a phase until they all eventually change. Diapause if the temperature is cool enough. They stop feeding, they stop egg laying, they head away under leaves, and in glasshouse structure, you'll find them in fans, you'll find them in the tubes if they're hollow, under benches and steel tubing. You'll find them anywhere they can find overwinter, they'll go and they'll stop feeding, and you'll not know they're there until they come back down the following spring. So that's how difficult they are to get rid of. We mentioned about how they spread via the ground, via crops, via machines, staff, air currents, the whole lot. Okay. I just want to give a few more details. So at different temperatures, we mentioned about temperature changing how the development of the population. Well, temperatures very much, you can see here, at 15 degrees, egg the adult takes 33 days, and they lay 80 eggs per female. At 20 degrees, they lay 120 eggs per female, and they take 15 days to go from egg to adult. At 25, it's down to 10 days. So it really does depend on temperature, how fast the population goes from one generation to the next. The population is 75% females. Okay, they can lay eggs asexually and sexually. And I'm going to pose a question and answer the question. If you have one female, how many individuals do you get in 33 days at 20 degrees C and 25 degrees C? So we're just assuming all the eggs hatch at once to make it easy for the calculation. So let's have a look how many individuals you get from one female. So you can see here the first scenario, one female, after 15 days, she has 120 eggs laid. Remember, 75% of her eggs turn into females. So those 90 eggs are females, and they all lay 120 eggs. So after 30 days, it's 90 times 120, which is 10,800 spider mite from one female after 30 days at 15 degrees C. But if you go to higher temperature, okay, then what happens? So we're looking at 25 here. In 10 days, there's 120 eggs being laid. 90 of them are females. So they then lay 120 eggs each at that temperature. Okay, but then you go to the next generation already, and then you then end up with almost, well, it's close to a million in 30 days. So it's a big difference depending on the temperature, how fast the population grows. So knowing that, how do we get rid of it? Well, we're going to be talking about the biological options. Obviously, Koppert are specialized in that, but we will talk about an integrated approach after I mention the different predators. So this first predator, again, it would be nice to show a video of it because I think they get a feel before we talk about it. So I'm just going to stop sharing this and go into the video again. So just need to find it, don't we, Connor? So need to actually just minimize that. Go to my tab. This one here. Share. Sorry about this. It's my inability to use this software. Stop sharing. Start again. There it is.
You can turn on the subtitles again.
Yeah, no problem. There we go. Stop sharing that. What happened there? Okay, so in the presentation. Here, can you hear that in the background? No?
No.
All right. Worry, there's a video up going on, it doesn't matter. Second. Video was playing in the background, just stop here. Sorry about that. Apologies about that. Okay. So you have an introduction to the predator. So that's the Predatory Mite Phytocelius. It's the predator that Koppert started the company with, and about 53 years ago. It's the very first product we ever had. It's still going strong after 53 years. No resistance to it across the world. We're finding new markets for it. It's growing in sales every year. It's a very good predator. It's a specialist, so it only eats spider mite. And what we've discovered about it is the color of the predator is dictated by what it eats. So if it doesn't eat spider mite, it's clear in color, but when it eats spider mite, it turns orange. So we've discovered another food source apart from spider mite. We always thought spider mite was the only food source, but we now know we can feed it in the factory without spider mite. So now we know that we can produce clear phytocelius in the factory, and then when we release them into the crop and they start eating the spider mite for the growers, they turn orange. So now the product you buy is clear and it turns orange over time, over several days. So, but in the crop situation, it will only eat the spider mites. There's nothing else it will eat. So it's what you call specialized predator. It means that it's very efficient at what it does, but it also means it has a weakness that when it runs out of food source, then it will die. So it can basically clear out a spider mite population for you, and then when the spider mite population crashes, then the predator then dies off. What you might notice here, the life cycle is shorter than the spider mite, which is why it can overrun the spider mite partially. So one of the reasons why it's good at overrunning, because it's got a shorter lifespan. At 27 degrees C, you'll find it's 3 days shorter lifespan than the spider mite. So it's generating itself every 7 days, the spider mite's every 10 days. So you can imagine it overtakes it. It lays 2.4 eggs per day, and an average of 53 eggs per female. So if I'm in a crop looking for a grower to check is it working, I'm looking for signs of the eggs of the predator. So here's the eggs of the predator. You see here with the arrows, they tend to be slightly oval and they're not clear. They're more like a sort of a peachy color or salmon color, and they're about 2 to 3 times the size of a spider mite egg. So I am looking for those. Once I see those, a lot of those, I know that the population is really taking off and it's going to overtake the spider mite population. You will also see here the larva down here in this picture. So you can see it's not much bigger than the egg. So it's sort of hatched out, got some legs in it. It's not fully orange yet, but as it gets older, it becomes more and more orange. And the adults are very orange in color. They've eaten a lot of spider mites at that stage. Okay. You see the picture here of all stages together: eggs, larvae, and adults. And here's a large picture of the adults with some spider mite eggs ready to be eaten. So again, it does depend on temperature. So you can see here, it depends on temperature and humidity. One of the weaknesses of this predator is it doesn't like low humidity. So if you have a humidity of 40, then a relative humidity of 40, then it's going to struggle. So at 21, it's still okay. 73% of the eggs turn into adults. At 80, you get 79%, but whenever you're getting at 27 degrees C, you see then you do have a struggle. You don't get much survival then of the, a lot of the eggs don't turn, you only get 7% of the eggs turn into the adults whenever you're 27 degrees C and 40% humidity. Now, 40% humidity is not that common, but it's just, it shows you what can happen in that situation. And above 32 degrees C, so in a heat wave situation, above 32 degrees C, you will see that this predator stops really developing. It doesn't want to lay its eggs. So that's a weakness in it. But if you get the conditions perfect, it's the perfect predator for controlling, for basically killing off hotspots of spider mite populations. One of the ways you could put it out, you can use a bottle and sprinkle it out, but you can also use what we call an air bug or a mini air bug. This is Koppert's invention. So we have these for customers. This is a handheld applicator. So you have this little drum that goes around. You have these apertures the whole way around the drums that can widen and close. So you have a good idea then whether what size you want it to be. The bigger the hole, obviously, the quicker they come out. So you get the setting right for the speed that you walk to put the product out from start to finish across the crop. And here there's a fan. So you switch the fan on, and when the rotating drum goes around, the product starts to come out of the holes, and then the fan blows the product across the crop a distance of 2 meters in any direction you want it to go. So it's quite efficient, very popular among our customers to use this device to spread the product. Okay, so products called Spidex Vital. You have 2 bottle sizes: 2,000 predators, 10,000 predators in the same bottle. So depends what you want to, how many predators you need, whether you go for the small or large bottle. They're on wood chip carrier, just so there's something for them to hang on to inside the bottle, and they're easier spread when they're on the wood chip carrier. Okay, so here you can see a picture of it being sprinkled out on the crop as well, so you can also do that. The next predator I'm going to tell you about is one that really goes side by side with the Spidex. So as well as the Phytocelius, you've got a predator called Neocelius californicus. Now, Neocelius californicus is what you call a generalist mite. So rather than being specialized, it can survive on other food sources. I'll not show you the video because I think you'll see a mite quite similar to the one you just saw in the previous video, but it's different color and shorter legs. So we'll just talk about it for now. So basically, it's less active than the Phytocelius. In other words, it doesn't lay eggs as fast. So, and it doesn't eat as many spider mite per day as the Phytocelius does. It eats approximately 10 spider mite eggs per day. But it has many advantages. So as well as eating the spider mite, it will also eat the citrus mite we talked about earlier on, which might occur on your crop. So there's something you can use against the citrus mite, because in my opinion, citrus mite are very difficult to kill with pesticides. I've seen it myself. So you might want to be thinking about a preventative strategy, and this mite comes with a preventative strategy, as in you can use a sachet. So you see the sachet has the hook, you hang the hook up on the plant. Here's the little hole here, tiny little hole, and that is big enough to allow 1,000 mites to come out of this sachet over a 6-week period. How do we know that? We put the sachets into containers, and we then actually count how many mites come out. Every batch of sachets we make, we have sachets put in the containers, and we count the mites that come out over a 6-week period out of those sachets. So that's how we know, and we do a continual check on every batch, and the counts get at least 1,000 mites over a 6-week period. So inside that sachet, which is waterproof, that's quite nice if you have overhead irrigation, there's bran, and inside the bran, and there are also some little sort of seed husks as well. And inside there, then there's a mite that feeds on the bran, and then basically the Neocelis californicus or the spical eat the bran mites as a food source. Meanwhile, they breed and multiply inside the sachet, and then as the population grows, they make their way. They feel they need to leave the sachet, and they make their way out of the little hole. Now, the first week you only get be 10% release, but the second, third, and fourth weeks are when the major release occurs. Fifth week starting to level off, and then the 6th week you're getting a decline in release. You can still get some release week 7 and 8, but it's not reliable. So we always recommend replacing the sachet every 6 weeks to keep a continual release of your mites out of the sachets. These sachets go probably, generally speaking, every 2 to 2.5 square meters of crop, you'll have a sachet. The rules change depending on the crop. For instance, a raspberry crop, you'd have 1 sachet per linear meter. A strawberry crop, 1 sachet per 2 linear meters. Ornamental crops, 1 sachet every 2.5 square meters. And that just depends on the crop situation, what the density of the sachets are. Other things about this mite that make it really good is it can also feed on pollen. So if you have a flowering crop, like a strawberry crop, for instance, or a flowering shrub crop, they will feed on the pollen in the flowers while they are waiting for the spider mite to turn up. They'll also feed on other types of insects. They'll feed on tarsen nemid mites, if you've heard of those before. You get tarsen nemid mites on many types of crops, cause the sort of curling of the leaves. Begonia mite might be a common name for a type of tarsen nemid mite you might come across. And they'll feed on them very easily while they're waiting on spider mites to turn up. They'll even cure the problem for you of that pest. They'll survive quite a long time without food, whereas the Phytocelius will not survive several weeks without food. You'll find that the Californicus will survive several weeks without food. So if there's no food at all, they will survive several weeks. They're more tolerant of low humidity, so on a hot, dry conditions, this mite will continue to do the work for you, whereas the Phyto wants to go and find somewhere a bit more humid to hide away from the heat. So that's why it's good. So it's good for humidity. It's got a wider operating temperature range, so it's more cool tolerant, more hot tolerant. So if you're into maybe 10 degrees, it still works. If you're up to way into the mid 30s, it will still work. So there's many reasons for using the Phytocelius, using the Californicus, along with the Phytocelius. So the two go hand in hand. So I think about prevention and cure, and they will quite happily live on the same leaf. I see it all the time, and no problem being side by side. You can also get the Californicus as a loose product, but I generally recommend the sachet as best value for money for customers. Okay. So here is how it looks. It looks a little bit different to the Phyto. So the eggs are a little bit smaller, rather than maybe being 3 times the size of a spider mite egg. They're maybe twice the size. So here's the spider mite egg on the left. Here's the spical, the Californicus egg on the right. Slightly oval, clear color. Here's like a nymph of it. As it eats spider mites, you can see it changes color. So it can be clear, but then the contents of the spider mite make it like a sort of brown color inside the body. So you're seeing it's feeding on the prey, which is quite nice. Okay. So the larvae tend to be a little bit smaller than the adults. The adults, the body shape's a little bit different to the Phyto. The Phyto is more like a bubbly shape, whereas this is more like a pear drop shaped body. And the legs are shorter than the Phyto, than the Spidex. The Spider eggs are a little bit faster moving and longer legs, and the spikle's got shorter legs. Okay. So we're moving on to the third option. What I should have said actually is the Spidex, by the way, the first product we talked about, you can use that outdoors or under protection. The Spical in Northern Ireland under regulations is restricted to glasshouse use only. Okay, it's not allowed outside, unfortunately, or it would be a very interesting opportunity for hanging on outdoor shrubs, but you can't do that under regulations. It has to be under license in a glasshouse. The third product, we're still applying for the license for Northern Ireland for it, but I believe already that is native. It's just we haven't got any proven records in Northern Ireland that it is native, but I'm 100% sure I could go and find it somewhere native. But the way things are at the minute, we have to apply for a license for it. It's allowed across the UK, everywhere else at the minute, and in the south of Ireland, but just Northern Ireland is a place we haven't quite got the license for it yet. But this product is a gall midge, and it's called Spine End, so Feltella Kurasuga. So it's just, and it's basically what you call a predatory gall midge that specializes on feeding on spider mites. So you can see the life cycle here. Egg, then you have the larva, but then pupate. It's almost like a little webbing on a leaf you'll see, and then you get the midge fly. And the midge fly likes to hide away during the day. It's really more, likes to fly at dusk and do all its egg laying and searching for where the spider mite populations might be to lay the eggs beside them. Let's have a little look at it. Here's the larva, and it's eating the spider mite. Okay. So again, 30 spider mites per day is quite a good predator. 100 eggs being laid per female. Takes 14 days to go from egg to adult. The adults only survive for 2 to 3 days, but they do all their egg laying in that time, breeding and egg laying in a very short time period. They're very good at searching out the spider mite populations. And I find it naturally occurring already. I see it. So quite often people get free bio. It's just there's no proven sort of research papers to say it's native, but it is native. We just need to prove that fact. You can see the eggs laying here. The egg, this is like a little egg on the hair of the leaf. Okay. So they're very good at hotspot treatments. Females can locate the colonies. They can send them out, but like the Spidex, they can do a follow a scent trail. They also like a little bit of honeydew, so that the adults can feed on a bit of honeydew to just keep their energy up. You can see the larva feeding again on this per spider mite. And the product comes in a tub. I was going to show you how to use this product. There's like a 30-second video we'll look at. So this tub has 250 of the gall midge ready to hatch out as pupa, and they hatch out. So you just all you do is put the tub. We'll show you how it works in a second. Let me see. Oh, show it to you how this works. This product. Again, I just need to locate the video. Must be more tabs, I think, somewhere. Okay. I think I've lost my tabs there. Let's just see.
Do you want me to open it up on my side?
If you want to, yeah. If you have the one, how to use, that'd be great. How to use Spide End.
Find it here.
It's only a very short video, but it tells you a lot more than I can explain by words, so it's worth watching. Would have been on that link I sent you. Yeah. I can click the link open again myself if you can't find it. I have the link here if you want me to click on it, Connor.
I have it here.
Have you? Okay.
I think it's the
Spide End.
no, maybe not. No.
No.
If you want to click on the link, sure. Oh, there. Yeah, got it here.
Okay.
Yeah.
So you can mark off with a label where you put the product, which is quite a handy feature. You just punch a hole in the top, set it into position. Try to direct sunlight, as you can see here, and don't want water getting into the hole. It takes about a total of 2 weeks for all the adults to emerge. So that's why you leave it in place for 2 weeks. Okay. I'll stop sharing. I'll go back to the presentation then, Colin. Do that right here. You're on there, Connor. Oh. Do that right.
Disappeared there. If you want to stop sharing it and share it again.
Yeah, it seems I've lost the screen, but right here. I think I've minimized the screen. Can't find the thing. Oh, happened. So, am I sharing? No, I'm not
Yeah,
sharing.
you're sharing now. Just
Yeah, I'm
make
sharing.
it
Okay.
into the full screen.
Okay. Sorry about that technical issue again. But this, you've seen the Mite, you've seen how it works. It's very easy to put out. There's very little labor cost involved. So you're just punching a hole. You're setting into the area. The top can do 100 square meters or even 1,000 square meters, depending on the population of the spider mite. You use the product whenever you see the first spider mite because you have to give it just a chance to hatch out and do its job. But it's very, very successful in spreading itself about in the crop once you use it. So hopefully when this year we'll have it available for Northern Ireland as well as a product we can use. We supplement the other two predators whenever we want to use it. Okay. So comparing the three products, the three different types of predator. As you can see here, we've got two specialists, the Fido, which is the Spidex, and the Spidin, which is the Feltiella gold midge. And then you've got the generalist in between, the Californicus, the Spikecat. And then you can see what they can and can't do. So obviously, two of them can't survive without a food source, the spider mite, but the other one can survive without spider mites, eating a whole range of other things, including pollen and other pests, and also can survive without food, full stop for longer. You can see here that the Fido needs high humidity. Feltiella is more tolerant; it can go for lower humidity, whereas if the Spical, the Californicus, really can survive in a lower humidity environment. The advantage the Spidex has, the Fido, is got a short development time, 7 days, so it can really outrun the spider mite. So it's a very good curative. The other two have got a longer development time, so it takes them longer to cure the problem. You see, the Spidex is a very good predator. The other, as is the Feltiella, but the other one's a moderate predator. So a moderate predation rate, so it takes longer to do the job. So you want it in there preventatively. And then it talks about the lifespan. So 30 days for the first two and 10 days for the Feltiella. Okay, so now we've talked about all of these predators. We're going to just look at the whole situation and look at the integration, how you do, how you integrate. So if you're trying to control spider mite, I suggest you got to think about 5 different things here. So we're looking at the first thing you really should think about is how healthy are your plants? Have you got a healthy root system? Have you thought about that? Because everything does start from that. If you've got a weak root system, the plants are going to go into degenerative mode, and that suits the spider mite. So we don't want that happening. So keep the roots healthy, the right nutrition. Think about the right moisture content. If you have to use beneficial microorganisms around the roots to help, that's also something you could think about. Have you got the right nutrient balance? This is an area that Koppert are really very interested in now. We're working with a Dutch company called Novacrop Control. And the reason why we're working with them is because they do sap analysis, which is not something a lot of people do. They do live sap analysis, and they can look at the nitrate content of the leaf, the actual nitrate levels as part of the nitrogen content of the leaf. And there's a lot of links being shown by research that directly relate nitrate levels in the leaf to how fast a lot of pests can multiply, including spider mites, aphids, thrips, and whitefly. So if we can find a way of growing crops with less nitrate as part of the total nitrogen, then we can reduce the speed that the pest will multiply, which then gives the biological control better chance to overtake it. So that's the first two questions you have to ask yourself. Don't point your finger at the biocontrol not working straight away. Think, have I got the right condition in the plant? Is the nutrient balance correct to reduce the pest pressure to give the bios a chance to work? Also think about your monitoring. You should be monitoring at least once a week. If you're not, then you're how on earth do you know what's going on? So you really should try to find an hour every week. I know that's very difficult if you're running a nursery, but then you maybe need to delegate to a member of staff if you can, if you're large enough to have staff members, and someone who's focused on looking for pests, including using hand lenses, looking under leaves, checking all the nooks and crannies around the glasshouse that these things are likely to be. Think about the cultural control. So how clean is your stock? Are you sure there's not pests coming on the plants? Have you double checked them before you set them out? I find spider mite quite often on a lot of young plants coming in from different sources. What about the weeds? Have you got wild strawberries? Have you got brambles? Have you got host plants for spider mites anywhere near the doors or around the perimeters of the glasshouse? Exclusion netting doesn't really come into it with spider mites, that's for other pests, but have you cleaned down all the surfaces over winter? Have you cleaned out, have you blocked all the openings in the pipes that maybe these spider mites are living in? Have you cleaned down the fans? Have you cleaned down everything that these could be overwintering? You got to get rid of the overwintering spider mite. Don't give them a chance to overwinter. Then after you've done all of those things, then consider the biocontrol, because you can't just use biocontrol if you haven't done the first three things correctly. Think about a preventative strategy with the Spical, and then think about the curative with the Spidend and Spidex Vital. And only then consider chemicals. We're going to talk about chemicals as a curative measure. You might consider sometimes using a chemical at the start before you introduce the biological, if it makes sense to do so, particularly if you've got plants that come in with spider mite on them from the propagator. And then you might also use them as a final cleanup at the very end if there's still some spider mite on there after the biologicals have cleaned up most of them. There's low toleration from your customer for any sign of pest, then you might be forced into a situation where you have to do a cleanup spray at the end. So in between, you could use your biologicals, and at the start and the end, you use the chemicals. Please make sure when you use chemicals that you've checked the compatibility, and Koppert make it easy for people to do this by having a free side effects app. Okay, so we're going to look at that in a second. So you've got the free side effects app you can download onto your phone in Google Play Store and also in the Apple Store. Just go into the Apple Store and the Google Store, look up Koppert side effects app. It comes up as a free app, download it. It's very user friendly, and I'm going to show you some of the results of it in a minute. So these chemicals that you might use, for instance, here are some of the ones that a lot of the growers I would work with would use or have used. So you've got Floramite. Floramite's a contact-only spray. It will kill all stages of spider mite, including eggs, which makes it very useful. It's also very compatible for biologicals, which we'll see in a minute. So this is my #1 go-to spray to work alongside biologicals in an IPM, Integrated Pest Management Program. Borneo, contact and translaminar. So it goes through the leaf, eggs and larval stages, not the adults. So you want to think about using that earlier on before you have a lot of adults. The good thing about it is it has got, it will hang around on the leaf for a bit longer. So it will have killing effect for a bit longer. It's not fully compatible with the biologicals, as you'll see. Apollo, eggs only, but it's very compatible with biologicals. So again, it could be used early on. Dynamac, contact and translaminar, so it goes through the leaf. It kills juveniles and adults. It's not known for killing eggs, so only partial control. There's another one I came across last year for the first time that's been approved for soft fruit. It's only once every 2 years, I think, in a crop. So it's not a lot of chances to use it. It kills mite stages. It's contact only. It's partially compatible with biologicals, but not that compatible. Not fully. It's more compatible than other sprays would be, but not as compatible as fluoramide. So let's have a look. I'm just going to share that screen. I'm just going to have to go out here to show you the compatibility thing I've done. So put back in here, is that right? I'm going to still have to go into the tabs again. Sorry. Let's go into the tabs. What's that? All right. Share. Here. Can you see that okay, Connor? Can you see that?
Yeah.
Okay. So here is I've done out on our side effects app. Okay, you can also do on our website all the compatibility of the different sprays for some biologicals. So let's have a look at this. I've just put in for interest one that's not for spider mite, trisopa, which is lacewing larva. So to show you that you can do a whole range of biologicals at one go. But the three we were focusing on tonight are the Feltiella, the Neocetus californicus, and the Phytocereus. So let's look at the sprays. So Dynamac here, you can see Dynamac, which is very commonly used, is not fully compatible. So let's explain what this means. So if we go down here, you'll see what it means. So green 1 means it's the most compatible. Then you have yellow 2, orange 3, and red 4 means the least compatible. So least compatible means it kills more than 75% of your biologicals. The most compatible kills less than 25%, and the other two are in between, as you can see. So that's what that means. So let's have a look at the table. So you can see it's 3s and 4s for the Dynamac, and it's for more than 1 week persistence. So for more than 1 week after spraying, it will kill the biological. So you've got to wait more than a week, less than 2 weeks, and you can reintroduce. So it will disrupt for more than 1 week, but less than 2 weeks, and then you can reintroduce. So it could be used, but it will cause disruption. Whereas if you think about the fluoramide, it's got no disruption here for, well, obviously for lacewing larvae, for the Feltiella, for the californicus, the Spical, no disruption. It has a little bit of disruption, just 25 to 50% kill for 1 week for the Phyto. But again, that's not too bad. You can reintroduce, and it's not killing them all, killing less than 50%. The Apollo is nice because it doesn't do any damage whatsoever, as you can see. But of course, the weakness is it's only eggs. But still worth using in a program. The Alta, not too bad here, you can see. Not as good as the Fluoramide, but again, pretty compatible with Lacewing. Partially, there's no data, unfortunately, for the Feltiella there. It's partially then compatible for the other two products. A little bit of disruption, but it says 0 weeks. So you spray it, within a day or two, it's safe to put the biologicals back in. You'll kill less than 50%. Flipper contact only, again, you think it'd be completely harmless, but it's not. It will kill a little bit of the spical egg here, you can see, like up to 25 to 50% of the eggs of the spical, and it will be knock out up to 50% of the population of the spidex. I threw in 2 other chemicals which are nothing to do with spider mite, just to show you. You've got to also think about your full chemical program here, because if you're trying to control an aphid outbreak and you try to use Desis or Lambda, then you'll find actually that these 2 sprays are very disruptive, incompatible really, because they take 8 to 12 weeks to clear. So for after you spray both of those chemicals, they're dangerous to the biologicals for 8 to 12 weeks. So unfortunately, if you want to kill off aphids, you've got to avoid those sprays. There's other sprays I can give advice on that you could use instead, but I just want to show you that you have to think about everything here. You've got to think about the whole spray program if you want to use biologicals even for one pest. Okay, so I'm just going to go out of this now. Stop sharing. I'll just go back into the presentation. I'll see my presentation with it. still in the thing. Anyway, that was sort of the end of the presentation anyway, to be honest with you. There was no other slides, so not sure. So I've covered everything I wanted to talk about, really. I don't know if there's any questions or have we got time at this stage. We're close to the time being close to the end now. I think I spoke on 10 minutes too long, maybe in my enthusiasm. But
No, you're fine, David. That was very interesting and very insightful.
yeah,
A lot of good information there
I
for
lost
the
a bit of
growers.
time there with the technical things. Sorry about that.
Aye, they're all good. Thanks so much for that. There's one or two questions came in. Just maybe to give a message to growers that are looking to incorporate biologicals for spider mite control. What would be your take-home message? You know, what would you recommend? Where would they start in regards to that?
Okay, so first of all, the first thing they'll want to do is look at, are they doing the practices we talked about? Have they got a balanced plant? Are they following the procedures of checking and monitoring for things so that because if they're not going to do that, don't use biologicals. You've got to be prepared to get the hand lens out. You've got to be prepared to check the crops, but we have to check the progress of the biologicals. So the first step is becoming good at scouting the crops for your pest and being aware of the pest and the life cycle of that pest. If you get into that mindset and you have a staff member who can do that for you, then we can start talking about biologicals. The other thing would be use the side effects app. We have to then look at your whole spray program and then take out the things that are going to be disruptive. But there's still plenty of options. There's still plenty of good chemicals out there. Sequoia, for instance, is a good chemical against the aphids, which we could use, which is fully compatible with the mites. So we could use Sequoia, kill off your aphids, and still use your Spidex. So we
Yeah.
just need to have a look at the whole list and get familiar with the side effects app and get your charts worked out for yourself. What chemicals you want to use and which ones you can't, you're going to have to stop using in order to take up this approach. So if that's helping what I'm saying, but it's just
Oh yeah.
changing the mindset, I think, really.
Yeah. Have you any questions, Kieran? You're on mute.
Two questions for David. If you check your plants coming in, if your nursery was free from red spider, and you check your plants coming in and you seen eggs on them, would you be inclined? What would you be inclined to spray with the Apollo, which only works by direct contact and which can be difficult to get 100% coverage, or would you wait and go for the biological control or a combination of the two?
I would definitely spray Apollo if I know I can get contact with it because we don't want them hatching. So I definitely I wouldn't wait for them to hatch because then we've lost the opportunity for that Apollo spray. So the Apollo would definitely go on, and I would then introduce Spidex immediately because there's no problem with Apollo and Spidex can go on the same week. So you could order the Spidex straight in, the phytocelius, get them released into the problem area, and they will devour those eggs. So the Apollo, anything that the Apollo doesn't stop hatching will be eaten by the Spidex. The Spidex is not poisoned by the Apollo, which is nice.
The second and final question, David. If you've been walking crops, especially in protected structures, have you, due to the mild January, have you noticed things more advanced than, say, the corresponding period than other years, especially pests? Have you seen them more advanced for this
The
time of
answer,
year?
the answer is yes. I was walking crops last week, and it's quite alarming how many aphids are present on the crops. Unbelievable. So aphids are going to be a major issue this year, from what I've seen last week on a range of crops. I was looking at crops, I was looking at wasabi actually, which is like an edible crop. I was looking at strawberries. I was looking at ornamentals, aphids on them all, and large numbers of aphids. And also whitefly, very very happy laying eggs right now, right through the mild winter. So if they're the two most likely to get going the quickest. But I would imagine then, if it stays mild, the spider mite will probably start to come out of hibernation a bit quicker than it would normally, and the thrips will get going very quickly too. So I think we're in for a bit of a bad spring, possibly with the aphids and the whitefly for starts. Yeah, definitely. These mild winters are a major concern. Also, I had a report there today from the distributor that two customers rang up with vine weevil asking for nematodes right now. So again, the vine weevil with the mild winters is pretty active. So, yeah.
Thanks, David. Thank you.
Good questions.
That's all the questions that come in, David, there. So, but
Okay.
if there's any others that come in, I can send them on to you if there's any other questions or anything.
Anything that'd be helpful. We just want to be of help, answer people's
Yep.
questions, just help them to get more confidence. The idea of going from complete chemical to maybe doing an integrated approach is something that's hard to get your head around. So we're here to try and answer those questions, fill the gaps in for people so they get that
Yep.
confidence to take the first step. And I'll just give you a very quick story about using biologicals. I tried to do a trial with a grower in a multi-span tunnel in nursery stock. The trial went wrong because Spidex moved across the tunnel to the control area. So basically put the Spidex out in one bay, and we tried to use the chemical control about 6 or 7 bays across. And the Spidex crawled the entire 6 or 7 spans within several weeks, found the spider mite population, and contaminated the control. So I was really surprised myself how fast the Phytocetus Spidex could move across looking for the prey. So it shows
Yeah.
how mobile they are. And that's a good news story, isn't it? Because it shows that they will move and they will go looking for the pest across tunnel space in a very fast fashion, actually.
Connor, if I could ask one more question.
Yeah.
David, the success of biological control and even chemical control is down to proper identification of the pests and the predators
Mhm.
by the grower.
Yeah.
I find, through no fault, it's very hard or there's a lack of good magnifying equipment or to help the grower identify or recognize or measure or observe the pests. And what's your experience, or what do you use to help you in when you're walking a crop to identify the pests?
Let me I'll show you now 1 second. But I realized that I had the props to hand, but I just have several things I was going to show you. So I have a hand lens. So we do give these out to customers.
What magnification is that up to?
So the one we use as advisors, we find about 90% of the time a ×10 does the job. ×20 sometimes is more useful, but nearly all the time ×10 does the job. So this is the little hand lens that Koppert give out to customers. You just fold it into position like that, snap, so you've got the perfect space for the right focus, and then you set it onto the surface and get your eye right down onto it, and you get the perfect focus. So we use those. I keep that in my pocket. I use that all the time. If I think I need a more detailed look at it, I might have a fancy hand lens like this with a little light on it. So you've got your ×10, or you've got ×25, I think it is on there, ×40. But again, they're very hard to use those because they're very small lenses. So you're really trying to focus on the detail. So I could use that. I also have a lens I put onto my phone. So I just clip it onto the actual lens here, and then I can look at the pest on the. It's very, very good at looking the pest on the screen of your phone and taking videos and photographs, actually. So then you can send those photographs or videos to your advisor for them to identify for you what you're seeing.
And we have one of those. What is the magnification on that one that you put on your iPhone? Is it 20?
It's actually really quite good. It gives a because you can zoom in, you get a much higher magnification.
Oh, yes.
It's very effective, very, very useful. So I would ask people to get them for their phones, attach them to their phones. Koppert are starting to make them. They haven't been issued out as a general release yet. Staff have been issued with them, but I imagine in the future they could be something that customers could get for their phones to take the videos, to take the shots, to send to the advisors to have a look for them. So that could be a way around helping. Just WhatsApp the information to the advisor.
I think proper identification is so important.
Yeah. So obviously I can't physically, or you can't physically walk all the crops, so people could send the photographs through the phones. to the advisors, we could start identifying things within minutes for people and send them answers back, and that would really help them to decide what to do next. So that might be a way forward, Kieran, on that one. Okay.
Yeah.
These are so important. And if I hadn't got one of these, I couldn't do my job properly. You really need to have this in your pocket. Times 10 hand lens.
Yeah.
Times. The only thing this is not useful for is tarse needle mites. Tarse needle mites are too small. But times 10, you need at least times 20 for that. Tarse needle mites. But all the other pesticides generally come across times 10 does the job. Right?
Yeah. That's very useful. That's good information for the growers.
Yeah.
So I think we'll wrap it up with that, sure.
No problem. That's great. Enjoyed myself there tonight, apart from the technical issues. I struggled a little bit, but
yeah.
There.
Thanks very much for that, David. Much appreciated.
No problem. Thanks very much.
I think most people have left. So they have. But
Is there anybody still on, Connor?
See, Finley's there. Finley or.